If 70 volt line, 100 volt line, high impedance is new to you, you're likely to find on the back of that something called tappings.
So the tappings, they figured it out with the math. There's a transformer in there, and for that voltage line, they tap it at what they call a wattage tap. It's not really a wattage tap. It's tapping the transformer for a specific impedance. So it tells that transformer at, say, a 70 volt line, voltage squared divided by watts equals impedance. So 70.7 volts is 4,998.49 divided by, say, a watt. Call it 5,000 watts. You know, we're friends. If I tapped it at 1 watt, that's really tapping it at 5,000-ish ohms impedance. If I tap it at 2 watts, it's tapping that transformer at 2,500 ohms impedance. The less impedance we have, the more wattage goes out. So if I keep lowering the impedance, I get more wattage, and if I raise the impedance, I get less wattage. So it's really not a watt tap, but it's an impedance tap. But instead of having everyone do the math, they just call it a watt.
And why are we going to use that? Let's use a ceiling, for example. Sure. Ceiling speakers. We've got 20 ceiling speakers in the ceiling, all with the same wattage output, but effectively I don't want the same output in different zones.
Well, it might be different ceiling heights, so we would use a calculation for the amount of wattage we need at that loudspeaker at that height to get a certain sound level at the listening area. So say if we're sitting on a chair, a normal chair, not one of these raised bar chairs, our ears are going to be about 1.2 meters above the floor. So I want my sound right at 1.2 meters to a specific level. The loudspeaker is going to put out a specific sound pressure level per watts that I give it. So say at 1 watt, at 1 meter, it's going to make 91 dB SPL. So if I have a 3 meter ceiling and at 1 meter, with 1 watt, I have 91 dB SPL. If I went down to 2 meters, closer to our listening level, now I just took 6 dB SPL off. If I go 91 dB SPL, take away 6, that's 85 dB SPL, so 85 dB for 1 watt. That should be good, but I need some headroom with that loudspeaker, so for program audio, I want 20 dB of headroom. So I need to get up to 105 watts. Now I have to figure out how many watts I put into the speaker to get 105. At 1 watt is 91. I double that to 2 watts, that's 94. I double that to 4 watts, that's 97. I double that to 8 watts, that's 100. I double that to 16 watts, that's 103. Okay, I'm going to tap it at 103 watts. Now I'll get a good constant 85 when I need it, but I have the headroom in program for explosions and peaks and whatnot. And now I have to calculate that loudspeaker at 16 watts at a 70 volt is probably going to give me about 532 ohms impedance. So I want to make sure I tap all the speakers, do all the math, figure out how many watts I'm using total and the final impedance on the line. I want to make sure my amplifier is not going to go below that. I don't want to kill it. So I have enough headroom, I have enough watts, the impedance is a good match, and bing, bang, boom, Bob's your uncle, and I got a good system. Now, if I lower or raise those, that will change the amount of wattage I need. So if I say I have a different low spot in the speaker, yep, I might only need to tap it for 8 to get the same result.
Plenty more information on audio installation, low impedance, high impedance, 70 or 100 volt line, available on howtoav.tv. If you've got a specific question, leave it in the comments section below. We'll get right back to you.